Alright, this is 2-1 notes, average rate of change. Do now please take out your writing utensil and notebook. Objective, you'll be able to find the average rate of change given a graph. Alright, as you heard the past couple of classes, you know that the average rate of change is the slope. So we have our slope formula, m equals y2 minus y1 over x2 minus x1. You've seen this quite a bit now. So just to recap, make sure you got this down pat. First, find me the slope of the following two coordinates. So now our number's getting a little bit bigger than we normally would see in class, because we're going to try to use as much real data as we can. 10 and 240. 10 is my x1. My y1 is 240. My x2 is 25. And my y2 is 810. We're going to plug these numbers in. We got 810 minus 240 over x2, 25, minus the 10. We crunch out those numbers. 810 minus 240 gets us 570. 25 minus 10 gets you 15. 570 divided by 15 gets you 38. This is the concept we need to make sure we master in order to do this material that's coming up. Alright, so now that we've seen graphs before, but did you know that we have to find the slope of any two coordinates on the graph? Well, you bet, because that's something we did. We had picked 2 points, and then we find the slope. So let's just focus when I just give you 2 points. So in this one, this coordinate right here is 3, 1. And this coordinate here is 16, 13. I now need to find the slope given those two coordinates. This is my x1, y1. And this is my x2, y2. So I crunch that out. 13 minus 2. Oh, sorry, that was a 2, not a 1. My apologies. 13 minus 2 gets you 11. And then 16 minus 2 gets you 14. So that will be... nah, silly me. 16 minus 3 gets you to 13. So we have 11 over 13. Let's do another one. So we just have a graph here. That's all I'm giving you. And your goal is to find the slope between these 2 points on the graph. So we have 216. And we got 2012. Here's your x1, y1, x2, y2. We subtract it out. 12 minus 16 gets you negative 4. 20 minus 2 gets you 18. Now we gotta simplify that down. Negative 4 over 18 simplifies down to negative 2/9. Alright, same concept, except the presentation just looks a little bit different. So this is the graph is presented a little bit differently. So in this case, it's a little bit tougher to see the x-axis and the y-axis. So you might have to do a little zooming in on your own computer to see what it says. It's okay if as long as you're close with these separate problems, I'm gonna be happy. So this blue dot, it looks like it's between 5 and 7, so I'm gonna say it's a 6. And the height looks approximately around 18, so I'm gonna say 618. Whoop. And this one, it looks like it's 44 and 62. So I'm going to say that's 44 and 62. So what I'm going to do there That's my x1, y1, x2, y2. I'm going to plug those numbers in. Y2 minus y1, so 62 minus 18 gets you 44. Divided by x2, 44, minus x1, which is 6. 44 minus 6 gets you 38. 44 over 38, that could simplify down to 22 over 19. Now 19 is a prime number, so I know I can't simplify it down any further. So 22 over 19 would be the slope between these 2 points, or the slope of that line that I just made. Alright, let's do another one. This coordinate here looks like it's 3 to the right, 10 up, hence why I wrote 310 there, which I'll give to you guys. Also a little mix of problems. This one looks like it's a little bit to the right of 41, so I call it 42. And it looks like it's on that line of 60. So it's 4260. So there's my x1, y1, x2, y2. We crush it out. 60 minus 10 gets you 50. And 42 minus 3 gets you 39. So we have 50 over 39. Which then that slope is 1.28. 205. A little irrational number. And that's the slope between these 2 points on the graph. Let's do another one here. So here's our problem. Try to make it bigger. So we got 31 to the right, 50 up, and 51 to the right, and 100 up. So 100 minus 50 gets us 50. Over 51 minus 31 is going to be 20. So we have 50 over 20. And that simplifies down to 5 over 2. So our slope is 5 over 2. Or 2.5. In this case, I didn't give you the 2 coordinates, so you're going to have to kind of assume what it is. It's 2 to the right, 15 up. So you have to practice identifying coordinates too. You can't forget on how to do that. And this coordinate looks like it's 10 to the right, 24 up. So it'd be 10, 24. 24 minus 15 gets you 9. Divided by 10 divided by 2 gets you, 10 minus 2 gets you 8. So this has a slope of 9 over 8. Alright. Now we could still take our same approach even when these graphs have multiple coordinates on it. So you're going to find the slope of the 2 blue given coordinates. So even when there's a whole bunch of coordinates, you could still do this. So you can see that this one purple coordinate, I'm going to make it purple, and this blue coordinate here, the purple coordinate looks like it's at 5, 17, and this one's at 18, 23. So 23 minus 17 gets us 6. 18 minus 5 gets you 13. So you have 6 over 13 is the slope between the purple and the blue coordinates. This one's 3 to the right, 2 up. This one's 22 to the right, 20 up. So 20 minus 2 gets you 18. 22 minus 3 gets you 19, so it's 18 over 19. The slope between these 2 coordinates. Or 18 over 20. Ooh, that shouldn't be 18 over 20. That should be 17. 19 over 20. Alright. Make it bigger. So you have 8, 24, and 24, 3. These do get harder. And there's really a lot of